So listen to the supplemental problem 315. You can find this problem in the course ebook in the Chapter 3 supplemental problems on page 19. Given this op-amp circuit, which is called a positive summer, could you find the voltage V out in terms of the two inputs V sub A, V sub B, and the resistors in the circuit? In the last supplemental problem, we developed a model for the non-inverting amplifier, so let's replace this by its model, and that'll simplify our analysis of the problem. From the plus terminal to ground, there's an open circuit, and between V out to ground, there's a voltage-controlled voltage source of 1 plus R2 over R1 times V1. Or I'll call this voltage V1. Now, since I have two sources, I could use superposition to find the results, so let's do that. If I set this source equal to 0, the voltage V1 due to V sub A is going to be a voltage divider of R sub B over R sub A plus R sub B times V sub A. If I now set V sub A equal to 0, making it a short circuit, I have the resistor R sub A back to ground. That's a voltage divider of R sub A over R sub A plus R sub B times V sub B. Then I have V1 in terms of the resistors RA and RB and the inputs V sub A and V sub B. And the voltage V1 is going to be multiplied by 1 plus R2 over R1. Let me write this 1 plus R2 over R1 as R1 divided into R1 plus R2. I'm going to multiply that now by this expression and by this expression. V out is going to be equal to R1 plus R2 over R1 times this expression, which is V sub A times RB over RA plus R sub B. And again, multiply this, R1 plus R2 over R1, times V sub B times R sub A over R sub A plus R sub B. So now V out is in terms of V sub A and V sub B. Be able to add these two voltages together, but now times two different scalars. So I can do any kind of a summation that I want to. And this is supplemental problem 315, a positive summer.